Hello and welcome to the chapter 7 video, where the bulk of this chapter, we're not going to do everything in this chapter. We're really going to focus on just-in-time manufacturing, lean production, and how we can analyze that as cost accountants. So with just-in-time manufacturing, this is the new pull system versus the traditional push system. Under the old system of inventory management, companies would dream up an amount that they believe they could sell. And then they would produce that many units and then store those units in a warehouse, have insurance on those units. Sometimes the units would go bad or deteriorate. Sometimes people would steal them. And then they would do all of these advertising and marketing things to push the product down the customer's throat. Well, that wasn't all that efficient. Inventory costs a lot of money. It costs money to store it. Of course, it costs money to insure it, all those costs that I just mentioned. So there is another system of dealing with inventory, and that's just-in-time manufacturing. And with just-in-time manufacturing, things are driven based on the customer's order, and we have an intricate network of supply chain components where we're working with our suppliers to ensure that we can get the materials, high quality materials, just in time to meet the customer's specifications. So it's not just us working in a silo and deciding how many units we want to sell and then pushing that down our customers' throat. We're sort of taking the lead from our customers and then working with all of our partners to ensure we can provide the customers what they want while maintaining the lowest amount of inventories that we possibly can. The interesting thing about just-in-time manufacturing is that we really saw how vulnerable our systems are to having just enough inventory on hand to meet customer demand during COVID. During COVID, that's why we had all of those supply chain issues, all of the goods that we were out of. Our systems were just so sensitive because we're used to not having a ton of inventory sitting around. When you look at the balance sheet of companies like Dell and other companies that employ just-in-time manufacturing, you'll look at the inventory balances, and the inventory balances will be really, really small simply because they just don't keep a lot of inventory on hand. So here are some other items that are included in the just-in-time philosophy. Yes, we're focusing on product quality and low inventory, but we are also involving our employees in every step of the process, and we empower our employees. Our employees are closer to our customers, they're closer to our products, they can make better decisions and help us reduce our production time. So on this slide here, you can see some of the approaches we'll take to reduce materials as they come in. I already mentioned we need to make sure that we have a valuable relationship with our suppliers to ensure we can get the materials that we need at the quality at which we need it within a specified reason of time. We'll have intricate procedures for employees to order materials. And of course, they can only order those materials from the approved vendors. So there's not a lot of at the last minute going out and investigating who can possibly give us the quality. If we look all that up ahead of time, we have a list of approved vendors, then our employees will know who to order from. And of course, we only order materials as needed. In terms of reducing work in process inventory, the key is to reduce cycle time, and all of these individual components make up cycle time. So when we talk about cycle time, that's the total time required to complete any process. So if I'm in the business of making Rice Krispie treats and selling Rice Krispie treats, however long it takes from the time I order my raw materials, the Rice Krispies, the marshmallows, the butter, all that good stuff, to the time where it is shipped out to my customer, that is an entire cycle time for a complete process. So it includes all of those individual components, and you'll be able to see the definition of each one of those components as we progress through the slides. With setup time, how long does it take to get my equipment ready to start this specific leg of the entire production process? Or if I need to switch from one product to another, How much time does it take to get my equipment ready to do so? For processing time, how long does it take me to actually work on the units? Not setting up machines, not getting people in place, but actually work on my units. This is the only element that adds value to the product from the customer's perspective. Remember, value is in the eye of the customer. So when we talk about things that are value added, it's what the customer would want us to do and want us to spend our time on. For movement time, how long does it take us to shift between actually completing things and moving those finished goods to the inspection station before we can ship them out to the customer? How long does that take? For waiting time, how long is it just sitting there? Remember, with just-in-time inventory, we don't want our inventory just sitting there. It can deteriorate. People can steal it. We usually have to pay for those storage costs. So how long are our units spending in a temporary storage area waiting to be moved or inspected or processed? And of course, we can reduce that time by using that that pull approach instead of that push approach, meaning we order things as we need them. And then inspection time, we're not going to ship our goods out to our customers without inspecting them to make sure they meet our quality standards. So how long does it take us to inspect those goods? And now let's look at some approaches to reducing our finished goods inventory. So we've seen it for materials, we've seen it for work in process. And now for finished goods, we can reduce inventory, or inventory is automatically reduced, I should say, due to a lower cycle time. So we just don't have a ton of inventories sitting there on hand. By asking our customers what they want, gathering information about what our customers want, we can come up with better predictions about customer demand. So we're not making too much. And then, of course, from an environmental perspective, we want to make sure that we are eliminating waste and engaging in continuous improvement, which, of course, allows us to use fewer resources in order to get to our finished product. So on this slide here, we can see how the traditional method or methods we use to measure performance were quite dysfunctional. So in terms of traditional methods, one of the things we tried to do to keep our costs down were to get as many discounts as we could. And those are usually quantity discounts, which means the more you order, the cheaper price you get. Well, when you do that, you have excess inventory sitting around and you got to pay for those storage costs, and the goods could go bad or deteriorate. Obtaining a lower price usually means that you may sacrifice quality. You usually don't want your employees sitting idle and having your equipment sitting idle. So, and of course, you don't want your employees sitting idle because then that means you're paying them for doing nothing, or the equipment is just sitting there, it's not being run. But by doing that, the production supervisor may not want to stop to solve a quality problem or inspect the goods, because then you're going to have employees waiting while you're trying to solve that quality problem, and the equipment's just going to be sitting there not used. Focusing on absorption costing was another traditional performance measure. And if you remember, with absorption costing, we absorb all of the manufacturing costs as a part of the product cost. So if we can obtain a low unit fixed cost under absorption costing, then we may feel like, oh, we're saving money because our product cost isn't as high. But using absorption costing, the unit cost is only lower if we produce more units, because we have more costs to spread those units across. So that would motivate managers to produce excess units that they probably won't even be able to sell. So that means they have to store it. Again, they produce those units so that they can get that lower fixed cost per unit. Now, under lean production, we're trying to eliminate inventory and reduce cycle time. So now, instead of focusing on getting a bunch of quantity discounts or trying to make the fixed cost per unit lower. We now focus on inventory turnover, and we're going to look at inventory turnover, gross margin return on inventory and investment, as well as cycle time and cycle efficiency, reducing that cycle time. So we're really going to focus on these first two, inventory turnover and gross margin return on inventory investment. You can take some time to look up cycle time and cycle efficiency on your own, and then we'll migrate or transition to a problem where we'll do a couple of inventory turnover and gross margin problems. So with inventory turnover, you've probably seen this ratio before in financial statement analysis. Inventory turnover gives us an idea of how many times we sell our inventory during a given period. We calculate it by taking cost of goods sold and dividing it by average inventory in dollars. Usually, the higher this number, the better. We can take inventory turnover and convert it into days by taking 365 and dividing it by inventory turnover. And then that tells us how long or how many days we have our inventory on hand. Again, generally with inventory turnover, the higher the number, the better, but it really depends on the industry. Now, with gross margin return on investment, we link gross margin to average inventory. So for every dollar that I have in inventory, what does that produce for me in terms of gross margin? So it's the gross margin earned for each dollar of inventory. Now, remember, with just-in-time lean production, we're trying to keep our inventory levels fairly low. So when we do this calculation, we may end up seeing more powerful numbers in terms of percentages. So we may see 200%. But remember, we're connecting our inventory levels to our gross profit. Of course, the higher the number, the better. All right. For cycle time, I told you we weren't going to focus on this, but with cycle time, we're taking all of the individual components of cycle time and we're looking at how long it takes us to do each one and we're adding them all together. But again, trying to get this number or keep this number as low as possible. And then with efficiency, because processing time is the only component that adds value, we can put a lens on processing time and divide it by cycle time to see how efficient you are. What degree do we eliminate, or to what degree do we eliminate our non-value added activities? All right, let's stop right there in terms of the slides and let's switch and take a look at a problem. We're going to do some inventory calculation problems here. Just one, but we're calculating two ratios. So we have Dell Technologies reporting the following data for year 8 and year 9. And it's in millions. It's fine. I don't need to put in all the extra zeros to do the calculations, but we'll see. So we have inventory for year 7, year 8, and year 9. We have costs of products sold for year 8 and 9, as well as gross margin for year 8 and 9. So we're going to use this information and calculate the inventory turnover ratio for years 8 and 9 and the gross margin return on inventory investment for years 8 and 9. Now, remember that inventory turnover is equal to cost of goods sold divided by average inventory. Now, average inventory turnover. I don't think I spelled that right. Average inventory is equal to beginning inventory plus ending divided by 2. This is why they gave us year 7. We're not going to be able to do the calculation for year 8 if we don't have year 7's information, because the ending inventory for 1 year is the beginning inventory for the next year. So let's jump right in and let's do year 8. So for year 8, we're going to take our cost of goods sold, which was 51,433. And we are going to divide that by our average inventory, which is going to be inventory for year 7, the 2538, plus the inventory for year 8, which is the 2678, all divided by 2. Now let's actually do it. Now for you, of course, this goes much faster because you don't have to type out all of the detail, but I want you to be able to understand why I did what I did when you go back and look at this later on. Okay, 2. All right, let me make sure I have my numbers in here right. 2538, 2678. I'm dividing by 2 and 51, 433. So that means I sell my inventory 19 times a year, or I turn over my inventory 19 times a year. Now, just for fun, we weren't asked to do this, but the day sales in an inventory really drives this home and really gives you an indication of how long it takes you to sell your inventory in a given period. So if I take 365 days and 65 and I divide it by that 19.72, then I can convert that into days. Now, when you are doing your problems in my business course, you're not going to have to do this, but I want you to be able to see that, yes, roughly 19 times a year equates to 18 days is how long I hold my inventory. Now, if we're talking about the produce section of a grocery store, 18 days is way too long. I would expect that inventory turnover to be a lot higher because I'm only looking at a 3 to 5 day window for having that produce on hand. So I'll just throw this in and call this days sales in inventory for year 8. Again, you don't have to do that, but it really drives it home. Now, I'm supposed to be typing in 8 and I keep putting in an asterisk. Oh, great. Day sales in inventory year 8. All right, now let's take a look at year 9. For year 9, we're going to go through that same process where we take cost of goods sold for year 9, which is 57,889, and we are going to divide that by average inventory. Now my average inventory is year 8's inventory, 2678, plus year 9's inventory, 3649. And all of that gets divided by 2. And let's see what we have. Divided by 2678 plus 3649 divided by 2. And I forgot to put in my extra parentheses here. Now, remember, the higher the turnover number, generally the better. So this is 18 times a year we improved. Now, just for fun, let's see day sales for year 9. And this is where we take the 365 and we divide it by the number of times. And now look at this. We're holding our inventory a little bit longer. So now it's taking us longer to sell, or we're holding the inventory a little bit longer. Took us a little bit longer to sell. And I said we improved. We did not improve. Uh, I guess I'm used to doing the current year first and the previous year second, but we did the last year first and the current year second. So we actually got worse. Again, remember, the higher the turnover number, the better. So we were better in year 8 than we were in year 9. And what brings that home is that I'm holding the inventory longer. Now let's look at the gross margin return on inventory investment. Now, for the gross margin return on inventory investment, I'm going to take gross margin and now divide it by average inventory. So now my denominator looks the same. So for year eight, I'm doing last year first. Let me remember that. For year eight, I'm going to take my gross margin of 9,818, and that is going to be divided by the 2538 plus the 2678, all divided by 2. $98.18. And now when we do this, we get 3.76 times or 376%. Remember, we are connecting our gross margin to our inventory levels. So for every dollar we have in inventory, it generates $3 in gross margin. And that's inventory on hand sitting there. Or I can take this and we can make this a percentage. Now let's see it for year 9. And this time I'm going to do what I should have did before, because my formulas are pretty much the same. I just need to change my numerator. So now 13,398. Well, that's the same. And then we're going to change this to 13,398. Oh, this time in year 9, in terms of gross margin return on inventory, looks like we improved. Now, for every $1 that we have in inventory sitting there, we can connect it to gross profit, or it generates 400% or $4 in gross profit. So you shouldn't just look at one of these alone. Of course, we would also look at cycle time and cycle efficiency as well to see how we're really doing when it comes to inventory, but there could have been a logical reason for why we held the inventory a little bit longer. Maybe up here, yes, we were turning over the inventory, but it could have been that we were selling out too quickly. And sometimes when you sell out of inventory, customers get frustrated and then they go somewhere else and purchase the product. So even though in general, the higher the number, the better, if the number gets too high, it could be an indication that there are stockouts, and those stockouts will make your customers unhappy. So never look at one ratio in isolation. Okay, that takes care of the full breadth of this chapter. I appreciate your time and attention, and I'm happy that I was able to put both things in one video for you. I hope you have a great day, and I appreciate your time and attention.